There was initially an infinitely dense body of matter. The matter exploded to form the present atoms, molecules, stars, and galaxies. Physicists have used this explanation for decades as their theory. But new research has introduced a new theory that suggests that the universe is not as early in its origins as people have believed. Alternatively, it may form part of a cyclical process where the universe is swept through cycles of expansion and contraction, perhaps in an eternal circle. One of the world's most renowned physicists, Brian Cox, has also challenged the Big Bang theory, stating that something cannot come from nothing. That is a salient point in the argument. In addition, James Webb telescope observations have yielded results in opposition to the assumption that the Big Bang was the universe's final origin. The question of utmost concern: if the Big Bang was not the beginning of the universe, then what? Follow along with us as we travel this journey to the beginning of the universe, wherein we go as far back into the Big Bang as we possibly can and present the answer to this question and countless others. If you want to be current about things having to do with the universe and its surroundings, subscribe to this channel, tap the like icon, share the video so it can reach a larger audience, and hit the notification bell. Scientists have constructed a sophisticated understanding of the universe in its beginning, referred to as the Big Bang theory. In this theory, the universe was smaller, hotter, and denser compared to what it was in the past. Around 13.8 billion years ago, at that time, all the elements that constitute our world were created within minutes. This theory says that our universe, stars, and galaxies once had a size comparable to a peach and a very high temperature, over a quadrillion degrees. Amazingly, this fantastic tale agrees with all observations just fine. Astronomers have studied from the leftover electromagnetic radiation of the early universe to the abundance of lightest elements and have found that all are consistent with Big Bang predictions. To our knowledge, this explanation beautifully fits the nature of our universe. However, despite its apparent potency, we know that the Big Bang theory is only part of the picture. There is a missing segment to this puzzle, and that missing segment is an account of the first few moments of the universe. This challenge is owed largely to the shortcomings of the physical theories that we employ. The union of general relativity and high-energy particle physics provides us with a helpful conceptual framework. However, as we move back through the universe's earliest moments, mathematical sophistication increases steeply enough that our current methods cannot provide us with reasonable solutions. One of the indications of this difficulty is the occurrence of a singularity, a point of infinite density in the Big Bang's origin. This concept means, literally, that the universe at some point was compressed to an infinitely dense and tiny form, which is absurd. To overcome this challenge, we need to go into new fields of physics, develop a mechanism that goes beyond these challenges, and provide a better description of the first emergence of the universe. Our current tools and theories are not robust enough to face this challenge, so we need to develop new physics that can cover and describe gravity and other forces of nature at extremely high energies. This is precisely where string theory comes in. String theory attempts to be a physical model which can unify the other forces with gravity, specifically at ultra-high energies. In essence, string theory proposes that it can provide an explanation of the universe's earliest moments. There also emerges within string theory the ekpyrotic universe, a term borrowed from the Greek ekpyros, or conflagration or fire. Here, it is proposed that what we perceive as the Big Bang was caused by some prior occurrence, thus positing that it was not an absolute starting point but only part of a larger process. Building on the concept of an ekpyrotic universe led to the development of a theory called cyclic cosmology. Although the cyclic universe was speculated about for thousands of years, string theory provides it with a solid mathematical foundation. In the context of cyclic cosmology, the universe works as if it repeatedly cycles back and forth between large explosions and collapses in an infinite cycle that stretches out infinitely in space and time in both directions. This cyclical cosmology hypothesis was provided by Nobel laureate physicist Roger Penrose. Penrose was interested in a highly intriguing mathematical relationship between the early universe, which was immensely dense, hot, and small during the Big Bang, and the future universe, which is characterized as immensely cold, expanded, and matterless. As per the hypothesis, these two phases become mathematically identical when they are pushed to their extreme limits. Perversely, The absolute absence of matter could be the driving force behind the creation of all the matter that exists in the universe. The Big Bang would then trace its origins to what remains almost imperceptibly after all matter in the universe is consumed by black holes that eventually dissolve into random photons in a huge empty expanse. The universe arises out of what, from a different perspective, amounts to very near nothingness, though this nothingness is itself still a kind of something forming a physical universe, if one empty one. The enigma is in how the same condition can be understood both as a cold, hollow universe and as a dense universe, varying with the vantage. The key to this is in a very subtle mathematical approach known as the conformal transformation, a geometric transformation which changes the scale of an object but keeps it the same shape. Roger Penrose showed how the hot, dense state and the cold, empty state are connected through the scale transformation. Synchronizing their spatiotemporal systems, although divergent in dimensions, they may be homogeneous in character while being of different dimensions. Penrose argues, however, that the concept of size becomes immaterial in such adverse physical conditions. In cyclic cosmology, the sequence of events evolves from an old cold condition to a young hot condition. The presence of the hot and dense state is a result of the previous cold and vacuous state. The causal relationship is not normal in terms of time, however, since in such extreme states size and time are no longer in their ordinary sense. The hot, dense state and the cold, empty state exist on two different timelines, so from the perspective of an observer in his own timeline, the cold, empty state would continue indefinitely. Physics and philosophy are intertwined in this realm of circular concepts. Cosmology provides elaborate and speculative explanations for the beginning of these cycles. But even if Penrose's speculations are accepted in cosmological evolution, an even more basic question still exists as to the source of physical reality itself. How did these cycles start? This leads one to ask why there is something and not nothing, one of the ultimate metaphysical questions. For our purposes of discussion, we are going to be examining explanations within the realm of physics, and there are three possibilities to consider in looking for where these cycles originated from. First of all, there can be no physical explanation at all. Secondly, perhaps there is an infinite number of cycles with each cycle being a distinct universe and the initial quantum state of each universe being dependent upon some property of the preceding universe. Thirdly, there is always the option of having a single cycle and a cyclic universe where the beginning of the cycle is explained by some property of its own end. These alternatives are attractive because they avoid uncaused events and provide a more complex explanation within the physical system. In the physics world, Penrose proposes the idea of an infinite loop of cycles from his knowledge of quantum mechanics. In quantum mechanics, the physical system exists in many states simultaneously until it is being observed, when it randomly collapses into one state. Penrose hypothesizes that every cycle is compelled by chance quantum fluctuations that produce variation between cycles. This concept promises the thrilling possibility of experimental physicists, as it suggests the possibility of detecting faint signatures or anomalies in the residual radiation of the Big Bang. What do you think? Let us know in the comments box. If you liked the video, don't forget to hit the like button, subscribe to the channel, and share this video so that more people can see it.